Hi, I'm Dr. Papia Bhattacharjee. In this problem, we are given the Maclaurin series for e to the x, and the series is right here. Now, using that, we have to figure out the Maclaurin series for a different function, e to the 5x. So, e to the x is given to us. Now, how do we find the series for e to the 5x? Look, all we are changing is instead of x, we have 5x. So, in the series expression, we just have to replace x by 5x. That's how we can get the Maclaurin series for e to the 5x. So, it's just like evaluating a function at a different point, right? So, look at all these terms, and wherever there is x, you substitute that with 5 times x. Okay, so the first term is 1, there is no x, so keep it 1. Then for x, you write 5x. Okay, third term, you have x square, so instead of that, you write 5x, the whole thing, square. Remember, instead of x, so consider that where there is an x, there is a box. So we have a box square, and inside the box, you write 5x. Okay, so don't write 5 times x square, but the entire 5x square. And then we'll have divided by factorial 2. Next term, we'll have 5x cubed instead of x cubed. And then 3 factorial. And then you can continue. Next term is instead of x to the 4, we have 5x to the 4 over 4 factorial and so on. So that's it. We can actually write down the Maclaurin series for e to the 5x using the one for e to the x. Now, if you want, usually we represent our series in a compact sigma notation. So, if you want, you can even try to write down this whole thing in a sigma notation. So, how will you write that? Look, these terms are 5x, 5x squared, 5x cubed, 5x to the 4th. Therefore, we have 5x to the power n. You know the variable is n. And then denominator, we have here we have nothing, means we have 1, which is 1 factorial, then 2 factorial, 3 factorial. So, we have n factorial, and n starting from which value? See, the first term we have to get is 1, and we can get 1 if n is 0, right? 5x to the 0 is 1, 0 factorial is 1. So, you start at 0 and go up to infinity. So, this is the Maclaurin series for e to the 5x. Thank you.